कुठे गेली आहे?
Okay, we'll start today's session. So we are currently learning the design just a moment. Wait for 4 to 5 minutes. Hello.
Okay, sir.
Yes, sir.
Yes, sir.
Yeah. Hello, are you there?
Yes, sir.
Okay. There is little problem to this my pen actually. Let's see how it works. Okay, little disturbance may be there. Okay, so we were discussing the design part last time. So I think there is some problem to this. Oof. Let's see, we'll try to solve this. Okay, so whenever we see say design, we get stresses within the member. Let's say if we have, all of you know, so once we have a beam, what forces are there within the beam? What forces we get in the beam? Due to load?
So upper portion there is compression, at lower portion there is tension.
Yes, so if this is the UDL, we get the bending moment. Let's assume this as a, say, simply supported for the time being. So this will be bending moment, and there will be tension at the bottom and compression at the top, right? So there is a bending moment. Let me. So there is a bending moment M, and there will be shear force also. All of you know the shear force will be there also. Like this, something like this. So you see that there is a maximum shear force near the support. So to the moments and shear force, there will be stresses within the beam. Okay, so the stress will be, there is some problem. So bending stress will be M upon Z. Okay. Then there will be shear stress. This is your bending stress. Then shear stress. V upon what? V upon
Area of the cross section.
area of the cross section. So there is some problem to this. So area of cross section means any area. If it is a rectangular shape, if this is the rectangular shape of this beam, let's say, okay. So this cross section area here, if I cut any section, let's say near the support, then this area, cross sectional area at this line will be this area. Okay. And who is resisting the shear? Because all of you know that if this beam will try to shear off also at different sections. Okay. Like this. So there will be two stresses. That means before understanding the design, we should understand the stress. So what do you mean by stress?
Internal resisting force upon area of
Yes,
cross section.
internal. Yes. So the stress is actually within the material. There is problem within the material. So let's see some simple examples to understand the stress first, then we will discuss upon the further things. So let's say I have one steel rod suspended. There is some issue with the driver of this pen actually. Let's say this is a rod and I am applying a force over here to this rod. Okay. Let me just draw. Let's say this is your rod. tensions. So what will happen if you apply any force here? Definitely it is a tension force, because this will lengthen its length, we can say. So it will extend. So what will happen due to this tension force within this material? Let's say it is a steel rod. So what will happen to that? Let's say this is a steel rod. Okay. क्या होगा इसका?
It will try to resist.
Yeah, so it will try to oppose this elongation, but definitely it will elongate due to some force. So let's say original it was a length L, but due to this force, it got extended by length delta L, let's say. Okay. And what else will be there? So it will elongate. That is the first observation. What will be the second observation? What will happen inside this material?
Diameter will reduce.
Yeah, diameter will reduce. Okay, fine. This will reduce. What else will happen? Due to this, what will happen? Due to this tension, there will be stress actually. So there will be sigma, we can say stress is denoted by sigma, and the stress will be T upon cross-sectional area of that. If it is a circular rod, whatever may be the, we can say, shape of this rod, area of that rod, cross-sectional area. So if I cut over here and then if I see the, let's say this is a circular rod. So this area is nothing but this. Now, there is one more term we have learned, that is nothing but there is a change in length. So there is a term strain. What is strain?
Change in length upon original length.
So we can say that there is a change in length upon original length. So this is your strain. आज बहुत problem आ रहा है कुछ तो. Okay, and this is stress. Now, as you increase this force, let's say previously it was T1, you can give any number, let's say 1 kilonewton, let's say. So let's say in the beginning it is 1 kilonewton. Then you will go on increasing this to 2 kilonewton, then 3 kilonewton, similarly. So what will happen as you increase the force? What will happen?
It will elongate more.
Yes, so there will be some deflection delta L1 in the beginning, then delta L2 after force 2 is applied. Okay, so similarly, this will go on elongating. And at the same time, as the T is changing, so stress will also go on changing, right? So I can say that strain will change because delta is changing. So this will change. So there will be strain will be epsilon 1, then first case, epsilon 2, 3 like this. Okay. And corresponding to this, there will be stress also, sigma 1, sigma 2. As you go on increasing the force, the stress will increase, and even this strain will also increase, right? And if you try to plot a graph of this, let's say I want to draw a graph of stress versus strain. So let's say this is your stress and this is your strain. Okay. So, you can plot this strain versus stress for every force, we can say. For T1 force, stress will be sigma 1 and strain will be this epsilon 1. So if you go on plotting this, so the graph may look like this. So let's say these are the points for every force increase. And if you join this, then what will happen after certain point? So let me draw this. So you can draw a graph of this. So this will be, let's say, and then after certain point, what will happen? If you increase the force, little change increase in the force is not, it will change strain very high like this. Okay, so this will be the case. So you can understand after this point, when you increase force, the strain is not linearly changing, so the way it was changing here. Okay, so that means strain the change in length is very high. So all of you know that whenever the rod gets elongates after some point, there is a neck formation, diameter is decreasing, some of you said. Then after that diameter is changing very much, or we can say this is a neck formation. Okay, so when there is a neck formation, then length will increase very high even though there is a little change in the force. Okay, now you can see this is the point. Till this point there is a stress and strain relation is linear. Okay, so as you increase the force, strain is also increasing linearly. Now this point, if I try to plot, so what this strain stress we call it as, what is the stress value and what? Okay, so what this point we call it as, what is this point on the graph, and what is the stress? Let's say I go
Elastic limit.
so we can say so we can say it is a elastic limit, and this point is called as the yield point. Yield point. Okay, and the stress corresponding to this yield stress we call it as a yield stress, and if it is a steel, then we can call it as Fy. So this is a yield stress. Yield stress means the stress, maximum stress till which there is a stress and strain relationship linear. Okay, so this zone we call it as a elastic zone. So if you release the force from this, okay, so whatever you are increasing this force T1, T2, T3, if you release that, then again it will come to its original position. So that is called as the elastic zone. And this strain is called as the elastic strain. Okay, and this is your yield stress. So whenever we design any structures, either it is steel structure or we are designing, they are in okay. So do we design whenever we design steel, do we design for Fy value?
No, sir.
So how we design then? What is the value we take in designing?
0.87 Fy.
Yes. So what is 0.87?
Factor of safety.
Yes. So whenever we design any material, we give the factor of safety to the yield stress. Okay. So generally, our design stress, we can say design stress is nothing but factor of safety. Either we can say factor of safety into 1 or divided by, let's say, into Fy. Okay, fine. This will be our factor of safety in this case is in steel structure, we take the factor of safety as either we can say actually it should not be written like this. Let's write something different. ऐसे नहीं होगा actually. So design stress is nothing but yield stress. If it is a steel, we write it as a Fy upon factor of safety. And what is the factor of safety for steel? So in the denominator, it will be Fy upon
1.15.
1.15. Okay. And 1 upon 1.15 means 0.87 Fy. So this is our design stress. So whatever steel structures we design it for 0.87 Fy, and that too in limit state method. Please try to understand it. Limit state method, not working stress method. This is with respect to the limit state method of design in concrete. It is for concrete, and reinforcement is high strength bars. HYSD, high yield strength bars. HYSD, high yield strength deform bars. Okay. So whatever reinforcement we are taking, that we call it as a TOR steel, we can say. So this is the design. That means we are designing here somewhere. So even we are not even designing at yield stress, we are designing at design stress, which is 0.87 Fy. So this is generally. Now, if I ask you, let's say the diameter of this bar is 16 mm. 16 mm is the diameter of bar. So if I ask you how much tension it can take, maximum design tension I'm talking. So if you want to design this bar, if you want to check the capacity of this bar, what will be the capacity of this bar? Design capacity. I'm asking design capacity. How much tension it can take maximum? Yes. So force is
Design
nothing but
stress into area.
force is nothing but. So this stress we call it as a permissible stress. Okay. So this is our permissible stress as per given in the code. Permissible stress in steel, reinforcement steel, we can say. So force is nothing but design stress into area. How much is the design stress?
0.87 Fy.
0.87 Fy. What is the Fy generally we are using currently? क्या value है?
450 or 500.
415 or
415
500.
now it is a 500. Now in market nobody is using 415. The people are using 500 mostly. क्योंकि वही available है. So if it is a 500 and area of 16 mm bar is roughly 200 mm square. Okay. So what will be the capacity?
0.87 500 into 100.
So in kilonewton I want. So what is the value of stress? 500 is what is the unit of this? Newton per
Newton per mm square.
So Newton, and this is mm square. Okay, so what is this for force? कितना आ रहा है?
870.
570.
870.
In kilonewton. $87 kilonewton आ रहे हैं ना? I think. Yes.
Yes, sir.
87 kilo. That means we can say this rod can take 87 kilonewton force, and that too HYSD bar.
So just wanna ask one question.
Okay.
So here 500 Newton per meter square or mm square?
Mm square.
Yeah,
Always stress is in mm square.
Yes, sir. Oh,
ये अभी ये
that
पेन
is
को कुछ तो
looking like
प्रॉब्लम आ रहा है, ड्राइवर का
meter
इश्यू कुछ तो
only,
है.
that's
हाँ.
why.
Yeah.
Yes, sir. Now Confusion is cleared. So now.
Right. So mm square will go and then number will come in Newton and then you can divide by 1000. So it will be 87 kilonewton. So this is the, we can say, so if you want, if you know the diameter, then you can understand what will be the capacity. Or if you know the force, then you can design the rod. Let's say I'm asking you, let's say the force within the rod is, so I'm applying the force of, let's say, 300 kilonewton. So can anybody tell me what will be the diameter of rod which you can use safely so that it will take the design, this design force? Now this is, the design is ultimate force. Please try to understand. Ultimate force. Don't forget, this is not working force, because this permissible stresses 0.875 is for limit state method. That means it is ultimate permissible stress. Okay. So you should take the force as ultimate. So this is my ultimate TU, let's say TU, PU, whatever you want to say. What will be the diameter which the bar can take it safely? Tell me the procedure first.
Firstly, stress is equal to
So all of you know
tension upon area.
Right. Now this stress is permissible stress.
0.87 into 500.
Now as this value will be in Newton per mm square, let's convert this in
2000.
into 1000 and divided by area is unknown to me. Now first area will be Fy is 500. Sorry, Newton per mm square. कितना है एरिया? एरिया रिक्वायर्ड $700 something. Yes.
हाँ
700.
700.
Here the 7.
Okay. So 700 mm square, let's say, I don't know. So now you can calculate the diameter. So this is nothing but pi by 4 d square, right? So you can equate to this pi by 4 d square. So how much will be the value?
So diameter is 29.85.
So it is something, phi is nothing but
Around 30 only.
30 mm. Okay. Your design diameter will be 30 mm. So this way we can design the steel, we can say. Okay, if you know the tension, you can find out the diameter, or if you know the diameter, you can find out the capacity of the rod. So the tension comes, so this problem is of the pure tension. Okay. This is a pure tension, pure axial tension, I can say. Okay. So there may be tension due to bending also. So all of you know that there is a tension due to bending here. Now, if this is the moment, so how can you calculate the tension in the bar? Now let's see. See, these are the very conceptual and fundamental aspects actually. We are not going in detail of design that is followed by our books and all, experts and all. I'm just discussing the conceptual thing. So as a thumb rule, or we can say as a common sense, what is happening that we are seeing, not much in detail about the philosophy of design. So let's say due to on this beam we have load of 10 kilonewton meter. And the span is 4 meters. Okay. So what will be the bending moment? Value simply
W-
supported. Let's assume it as a simply supported.
WL is square by 8.
So M is nothing but W means 10, L is 4 square by 8.
20. 20
It will be
kilonewton
20
meter.
kilonewton. Okay. Kilonewton meter. So all of you know that due to the bending moment, there is a tension at the bottom
Yes, sir.
and there is a compression at the top. Okay. And let me assume this tension, let's say we will provide some steel over here, isn't it, for taking the tension. So I am interested in designing
sir.
this blue
Sir.
color bar. Okay. So
Sir.
we want to play. Yes.
सर
हेलो
बैकग्राउंड से आवाज आ रहा है सर.
हाँ कोई तो म्यूट कर
कुछ ज्यादा ही है सर.
हाँ ओके ओके फाइन. Okay, so I know that there will be tension at the bottom in this concrete beam. So, and concrete cannot take the tension. So we need to provide the steel here and we need to design this steel. Whenever say I want to design the steel, that means I want to put the reinforcement bars in the beam. So I will provide these bars at the bottom because the tension is at the bottom and you can see the bending moment diagram here also. Bending moment is maximum at this center point. And you want to design this. So can anybody tell me by common sense, simple method, what will be the, how to calculate the tension in the bar? You know the bending moment, how to calculate the tension? And let's say the
So we can calculate by sigma equals to m by z. Then first we will find out the sigma and then we can use m by z.
Okay, but I'm expecting still very simpler method. Okay, I'll discuss the truss analogy method actually, which is very simple. So here we are going to put bars. I don't know how many bars will come here. And let's say this distance till the bar is let's say 300. ये 300 है समझो. So this distance is 300 from the top face till the bar center. Okay. Now all of you know that what is bending moment. So bending moment is what? If this is a C and if this is a T, and if you know the distance between the two,
Force into lever arm.
yes. So this distance you know. So moment is nothing but force either C into D or T into D. And I know the moment. So my moment is how much? 20 kilonewton. 20 kilonewton meter. So let me write in meter only. And then T is unknown to me. And D is how much? 300 mm means
300.
Let's say 0.3 meters. I will make it meters only. So this is my meter and this is my kilonewton meter. So what will be the tension?
66.67.
let's say 67 kilonewton
67,
is the
yes, sir.
force. Now once you, and see, I'm considering this as a ultimate load, or WU. Please try to understand. This is not working load. This is ultimate load. So my moment is also ultimate moment, that is MU. So my tension will be also ultimate tension, TU, let's say. Now tell me how many number of bars you will provide. So how to calculate the bars, you know. If you know the tension, you know how to calculate the number of bars or diameter of bar. So we know that
0.87 FYST.
this is sigma y, means we can say permissible stress is nothing but force upon area.
Tension upon area.
And you know that permissible stress, you know the tension, so you can calculate area is equal to tension is 67 kilonewton. So let me convert in Newton divided by permissible stress sigma y, that is 0.87
FY.
Fy
500.
means 500. Let's say. So what will be the area?
So
In mm square.
154 mm square.
154 square. Now, if you want to provide the steel in the beam, let's say this is AST. So if you want to provide the steel in the beam, you should know what diameters generally used practically. So anybody knows what kind of diameters we use practically in design? और स्टील के कौन कौन से बार्स रहते हैं हमारे डायमीटर?
10, 12, 16, 20, 25.
10, 12,
8, 10, 12, then
16,
10, 10, 16, 20,
20,
25.
25, and
28.
28 generally, okay, it's very rare, but yes. So these are the main bars we use in on site actually. And if you know the area required, so this is my area required for that tension. Yes. So this is my AST required. Now, whenever you are using designing any beam, we provide at least 2 bars, right? Minimum 2 bars are required because we want to hold the stirrup also. So now tell me what diameter you will choose and how many number of bars. So for that you should know what is the area of 1 bar. Okay. So what is the area of 8 mm bar? Single bar I am saying. It is near to 50 mm square.
78 mm square.
10 is I think kitna
78.
78 hai. 12 ka 113. Okay.
200.
200. Okay. Now your area required is 154. So which diameter you will use and how many number bars? So if you use 8 diameter, how many bars you will require for this design?
3 bars.
So 154 divided by 50. Kitna aa rahi hai?
3 aaya. 3 bar.
3. So it will be 3. If you use 10 mm diameter bar, 150 divided by 78.
2 bars.
2 bars.
So you can choose any diameter and then you can put the bars. Okay. So let's say any choice. So this my design is very easy now. Generally we don't use 8 mm bar at the bottom. Generally I'm saying. See, there is nothing wrong in using that, but you can start with 10 mm bar. So I will use 2 10 bars, 2 Tor 10. This is my simple design, I can say, as far as the beam is concerned. Okay. So you got the concept of stress and all these things, basic. This is not the method which we are using in RCC design actually, but by this method, you quickly check the design whether it is right or wrong. Fundamentally, I'm saying. See, I know that there is we have the different formula for AST. Do you know this AST formula is there in RCC? 0.5 FCK upon Fy and square root.
Yes, sir.
That formula is there. So we design by that formula only because it is based on the limit state design philosophy. And we are taking that parabolic area of the concrete and all that. There are a lot of design philosophy behind that. But once you calculate the steel by that rigorous methods, detailed methods, or you do the design by say, let's say RCDC software or any software, and if you want to quickly check this, then you can quickly check like this. Just check the moment, then divide the moment by lever arm, this one D, get the tension, and then use this permissible stress and all this, and you will get the area quickly. It will take hardly 2-3 minutes to get the AST required. And whatever steel design is done by the RCDC software or a Excel program or whatever softwares you are using, you can quickly check whether it is wrong or right or what. Is there any say? So this is a quick method, and this is the understanding also regarding the moment, tension, stresses. Okay. So this is the way we can quickly check the results, and these are the concepts. So this was with respect to the steel material. So here you can understand whatever may be the material. Now we have taken this graph for the steel, and if I divide the stress by strain, what this term we call it as?
Modulus of elasticity.
So we call it as a modulus of elasticity. Actually, it is developed by the Hooke. Actually, this is the Hooke's law. Actually, stress and strain relationship is linear. So this is a Hooke's law. So the meaning is, if you apply the force tension, it will elongate, and if you remove this tension, it will again come to its original position. So the maximum force till which it regains its original position, that we call it as a elastic force. And the stress corresponding is elastic stress, that is yield stress, we can say. And the ratio of stress upon strain is the elastic modulus or modulus of elasticity. So this is also an important term in design. So anybody knows what is the value of modulus of elasticity for steel? Steel का कितना है?
2 into 10 to the power 5 Newton per mm square.
So steel का ये E value है 2 into 10 raised to 5. What is
Newton
the
per
unit?
mm. Newton per
Unit क्या
mm
है?
square.
So Newton per mm square, because you know that stress upon strain है ना ये. So stress is a unit of Newton per mm square, and what is the unit of strain?
Unitless.
Strain का unit क्या है? So it is unitless because length upon length is nothing, means no unit. So this is the modulus of elasticity of steel. Anybody knows what is the modulus of elasticity of concrete?
So 1 by 10 to 1 by 15 of that
Everybody
of
knows,
steel.
as per code is one empirical formula is there, 5000 root FCK. Okay. Now let's take FCK as a 25. Correct?
Yes, sir.
So 2 into 10 raised to 5 means how much? 2 lakh. So this is 2 lakh and this is 25,000. So how much is the difference? You can say, if you calculate the ratio, कितना ratio है इसका? 2 lakh मतलब it will be
8, around 8.
8 times. Yes. So your modulus of elasticity of steel is 8 times more than the concrete. In general, I am saying. Okay. So tell me, if the beam, I am preparing the beam, let's say, using only concrete material, let's say first. So this is a beam which is of concrete and I am applying the load. And due to the load, what happens? There is a deflection of the beam. Okay. So there is one case, the beam is steel beam, and second case, there is a concrete beam, let's say. Now, which beam will deflect more for the same load?
Concrete.
Steel beam deflect more.
No, please. Now this is
Concrete
very
will deflect more.
concrete will see, because the modulus of elasticity is very high for this. So it will, you see, modulus of elasticity means what? Stress upon strain. Okay. So see, for deflection strain, you know the change in length. So for changing a change in length, actually, it is requiring more force, because you understand by this ratio. So it is a 2 lakh Newton per mm square. So it will, steel will deflect less actually, and concrete will deflect more. So if you have the E value more, then it will deflect less. Now I will tell you one formula for deflection. Let's say if it is a beam, then for simply supported, what is the formula?
L by 20.
5 upon 384. WL to the power 4
L to the power 4 divided by
upon
EI.
EI.
Upon my EI. That means inversely. So the more it is having value, then delta will be less. Correct. So my E value for steel is very high, and that's why delta will be less. If E is less, delta will be more. Correct. And
Yes, sir.
it is also inversely proportional to moment of inertia. We have already discussed. If the I is more, then delta will be less. Okay. So I can say if I is more, E is more, delta will be less. Correct. So that's why, and even you can understand through the stress and strain relationships. Now imagine this, think over it. So if you are, say, even you know how to calculate the strain. Na? Let's say if it is a steel rod that we have discussed. If you are applying, let's say for this steel rod, you are applying 10 kilonewton force. Okay. For the steel rod of the same diameter, diameter, let's say square steel rod is of diameter 16 mm. No, 16. Let's take more. 100 by 100. Let's say square. So let's say the cross section of this rod is 100 mm by 100 mm, and apply force of 10 kilonewton to that. And note delta L. And now if you take this 100 by 100 concrete rod, let's say concrete rod, and then you apply, then what will be the delta L? So it will be definitely concrete will elongate more. Okay. So in this case, actually the concrete example is not suitable. Let's say timber. Let's say the 100 by 100 mm steel is there, and 100 by 100 timber is there. So who will elongate more, timber or steel? Yes, who will elongate more, steel or timber? Or anybody knows E value of timber? Is it more than steel or less than steel?
Less than steel.
Yes, so E timber is less than steel. See, I don't remember this value. Timber. I'll share that value with all of you. What are the E values for different materials? Okay. Now, so this was with respect to the steel material. So whenever we deal with the design, we are dealing with the materials, different materials, and for different materials, the permissible stresses are different. Their elastic modulus or modulus of elasticity, they are also different. Okay, so these two terms are very much important as far as the design are concerned. E value and permissible stresses. So permissible stresses may be different for different actions. This was the permissible stress 0.875 was for now let's see the material as a concrete material. Now we'll discuss regarding the concrete. So we steel. Okay. So whenever we test the concrete material, so we have taken the test of steel previously. Now, can the concrete take tension?
No, sir. Little tension.
Yeah, so almost negligible we can. So that's why we don't test concrete for tension directly. So we apply the compression on the concrete. So all of you know that we are testing cubes. Cube test we do to check the capacity of concrete. Okay. So we are testing the cube. All of you know that we use UTM for testing of the cubes. And
Yes,
in UTM, we are applying the compressive force. Please understand. We are applying compressive force because we cannot test the concrete in tension because the important capacity is compressive capacity only. Now tell me, if you apply this compression, I'm just trying. See, we generally test cube only, but I'm for the example purpose, I'm taking this as a column just to understand the concept on a bigger picture. For this, due to this compression, what will happen to this pillar? So its length will reduce. Yes.
Yes, sir.
So,
So if it is a original length L, and this will be the change in length after application of the force delta L. And the philosophy is same: stress, strain. You have to calculate the stress sigma 1, sigma 2, sigma 3 and all. Okay. So
yes,
similarly,
sir.
you go on increasing the compression C1, C2, C3. As you increase, the stress will increase, and due to as you increase the force, there will be change in length. So corresponding to sigma 1, there will be strain also, epsilon 1, epsilon 2. And you note down all these numbers, stresses and strains, and plot a graph similar to steel. So this is the standard method of plotting a stress strain graph for any material. Now, when you do this, any material first shows the linear graph. So whenever you plot points, you will see that it will first show this linear. So this will be first linear, first one. And after that, it will be non-linear, or you know that strain will increase more for the same force. And after some point, it will fail. So in the similar fashion, steel structure also we have done. Yeah, what is happening here at this end, it will fail. Fail means what? Steel will cut. So see, here the neck will form in the rod, here somewhere, and it will go on elongating, and so elongation will be something like this. See, ऐसे कुछ तो neck form हो जाएगी ना rod में, yes or no? Because you are
Yes,
pulling
sir.
this.
Yes, sir.
So this neck will form. Neck means the diameter is very less, and after some time, as you still go on increasing the force, at some point it will break like this. So that is the force at which it is breaking. That is the ultimate force here, we can say. This is the last point of the graph. After that, the piece got broken. Okay. In the similar fashion, for steel, concrete also, we will do the test. And this is your failure point or ultimate point, you can say. Ultimate stress, ultimate strain, and failure point. After that, the member is failing. Now here, what is this stress corresponding to this? And what is this point we call it as? ये point कौन सा है?
Yield point.
Yield point only. And the stress here is yield stress. Now in yield stress in concrete we call it as what we call it as? Yield stress को क्या बोलते हैं? Nomenclature क्या है उसका?
FCK.
So it is FCK.
Characteristic strength.
So we call it as a characteristic strength. So this characteristic strength means what happens? We test different cubes actually in the lab. And if 95% samples are passing, then whatever is the stress, whatever the grade we get out of this stress, yield stress, whatever yield stress we get, we call it as FCK actually. You just go through the IS code, you read that all the definition and meaning of that. But generally we say that whatever samples we are taking, 95% should pass. And then you can take their values as a FCK. So this is a FCK value. And do we design for FCK? FCK को design करते
No,
हैं?
sir.
So we use factor of safety. So what is the factor of safety for concrete?
1.15.
1.5. 1.5 only.
1.1.
1.5, not 1.15 is for
Steel.
Steel.
Yes, sir.
yes, steel is 1.15, but for concrete factor of safety is, so
1.5.
factor of safety for this is 1.5. Now there is one more factor of safety.
Shape factor of safety.
So shape factor of safety we can say. See, as we are testing the cube, all of you know that we test in the lab the cube. This is we are testing, and all of you know that whatever beams, columns or slabs are there in the building or in any structures, they are not cubes. They are having different shapes. Beam is having a rectangular cross section and there is a big length, we can say longer span, 4 meter, 5 meter long beam. Then the width of the beam, let's say 230, depth of the beam is let's say 600. Then column is also having the same sizes. Then if you consider the slab, thickness is 150 mm and there is a total area of 4 meter by 4 meter, let's say. So it is not exactly cube. So whatever structures we are designing, whatever members we are designing, they are not cubes. They are having longer length, more area for slabs like that. So to represent this shape, so it is an indicative specimen or sample which we are testing. So there has to be some factor to be considered for this shape, because this is different than your real structure. So the real structure is different than your cube. It is not exact to the real structure. So to resemble that or to take care of this shape, there is one more factor which we add apart from this factor of safety. Let's say we can say it is a, as you said, let's say shape factor or whatever you want to say. But this is also factor of safety. So additional factor of safety to be considered for shape. And that is how much? Kitna hai wo?
0.67.
So this is also 1.5 actually, ideally. So we divide the factor of safety to the stress. That's why we are taking this. So this value for shape factor kitna aega ye? So let's say this is, so FCK upon 1.5. FCK upon 1.5 kitna aega ye? This is, as you said, 0.67 FY. Okay.
Yes, sir.
This point is 0.67 FY. This is for shape, and additionally we want factor of safety for design. So it will again come down here. So I will divide 0.67 FY by again 1.5. So 0.67 FY divided by 1.5 kitna aega ye?
0.45 FCK.
So it will be 0.45 FCK. Okay. So this is the value we take for the design purpose. So if you want to design the concrete for compression, then you can use this formula. Now I want to ask you, let's say this is a column. Now consider, just ignore this length. Let's say this column is very short. The height is very less. Okay. And you are considering this. And if I ask you, let's say C1 is C1 समझो 1000 kilonewton है. And the column is very short, the height is very less. So I am ignoring the length factor, whatever is there. So if you want to design this column for 1000 kilonewton ultimate force, okay, this is ultimate PU, let's say, let me call it as PU. So how much size you will provide? Let's say I want to design square column for this force. Sorry. Square column. So what size you will choose so that it will be safe? It will be safe from design point of view. So what is the size required? Tell me. What now this is nothing but what? Permissible stress. So what is the permissible stress in concrete? So sigma C I am talking because permissible stress in compression is nothing but 0.45 FCK. This is the permissible stress in concrete in compression. Previously in steel case we have taken permissible stress in tension, right? And we take the permissible stress in concrete in compression only because concrete can take only compression. So we are not interested in the permissible stress in tension. Okay, so we are ignoring itself. So there is no need of understanding that concept. Now you know this permissible stress and you know the force. So what is the size of concrete? Tell me. So stress is nothing but, so we are comparing this stress is nothing but what? Force upon area. Okay. Now you want area. So force upon stress, permissible stress. I am talking permissible. And what is the permissible stress in concrete? And now you know, let's assume the grade of concrete as 25. Convert that into Newton, then 0.45 into 25. Assume grade of concrete as 25. कितना आएगा?
Four times 8 and then 9. 88,889.
Yes, sir.
4 times 8.
5 times 8, sir.
5 times 8.
Yes, sir.
Yes, sir. Round off, it will go to 9.
Square root of this will be
19,000 area.
98. 298. 300.
98.
298.
So let's say around 300 will be the size. So 300 by 300. Okay. So this will be my concrete size. If I want to design only concrete section for this force, this will be the size, cross-sectional area. Correct. So it is
Yes.
same as we can say steel also. So here you can understand by these examples that whatever may be the material you are using, first of all, you should know their stress and strain graph. Then you should know the yield stress. Then you should know the factor of safety to be considered for that material. Now, factor of safety for different material are different. Do you know this? So see, now just check out this factor of safeties. And once you know the factor of safety, you calculate the permissible stresses. And once you know the permissible stresses, then you can design any section for that material. Yes or no? So you should know the
Yes.
force, and then you know the permissible stress. You can calculate the area of cross section of that material.
Yes, sir.
Okay. So now if you use this philosophy, then you can design any material in the world. Okay. Provided you know the stress and strain graph along with the factor of safety. The factor of safety is generally different for different materials. And if I ask you, so what was the factor of safety for concrete? So let's say material. And this is a factor of safety. Okay. So let's say steel, how much was the factor of safety?
1.15.
1.15. And concrete, it was,
1.5.
so it was 1.5,
1.5.
and again it was 1.5, and again it was 1.5 for the shape factor, right? So I can say 1.5 into 1.5. Can I say this? So how much is near to 2? Something 2, near to 2. 2 to 2.3. Yes or no? How much is 2.3, na?
2.25.
Okay, so it is 2.3,
2.25.
let's say. So it is 1.15 for steel and 2.3 is more for concrete. What is the reason having more factor of safety for concrete?
Concrete is better.
Sir, better quality at the manufacturing
Yes, so
in steel.
steel is manufactured in factory first. Then second is steel is very homogeneous material. The material is only steel, right?
Yes, sir.
Purely steel, so it is homogeneous. The properties within the material are same, uniform in all directions, and that's why. And it is also fabricated or manufactured in factory under very much quality control, and that's why the factor of safety is less for steel. If you consider the factor of safety for concrete, it is more because all of you know that it is made up of cement, aggregate, sand, everything, and water. And you cannot assure the quality of concrete same everywhere because the material, aggregate, sand is different at different location and so on. So that is one of the criteria. It is more. And the second criteria is the shape, because we are testing the concrete in lab using cubes and the real structure is different. So this factor, so that's why this factor is more for concrete. So in general, we can say the factor of safety depends on the quality of material, which is possible. Whenever you use any material for construction or for design, what kind of material you are using, the factor of safety changes according to that. So we can say, and generally for wood, it is also changing as per different wood. All of you know that there are different types of wood, timbers. Whenever
Yes,
see,
sir.
generally in foreign countries and in India also, but some locations people are using wood also for form work and all. All of you know that wood we are using for form work and shuttering. So that means wood is also a structural material, we can say. Even the houses, bungalows done in other countries, they are also made up of wood. Columns are wood, beams are wood. Then there are plies also, so wooden plies and all. So there are a lot of variety of wood available in the market. That means the factor of safety will be different for different wood types, and the permissible stresses or stress and strain graph is also different for different types of wood. And generally wood is also, we can say,
Just
as
vision of
the quality is
Apparel
not
look the
assured much compared with the steel and concrete. So wood is having more factor of safety. It is around 8. I'm just giving example for comparison. So it is around 8. Okay. So you can understand for different materials how the factor of safety is different. For the same load, for same moment and all, we are taking this. And also we have different values. So E for steel is more. Okay. Very high means 2 lakh. This is 25,000. So lesser than that. And wood will be still lesser than that. So the E value will be different for different materials. And factor of safety will be different for different materials. And that's why. And stress and strain relation is also different for different materials because the capacity of the material is different. So the modulus of elasticity is different for different materials. Permissible stresses are also different for different materials. Because permissible stress is nothing but factor of safety into the yield stress. So you can observe, you can go refer the books, or you can go on the internet and find out these values. E value for different materials, yield stresses for different materials, and factor of safety for different materials, and get the permissible stresses. Okay. Now let me correct one thing. Now steel I have discussed, but there is little error we can say regarding the stress strain graph of the steel. Okay, so all of you know that there are two types of steel materials available in the market. One is the high grade steel. High grade steel means, let's say this is my mild steel. Mild steel, and this is high grade steel, HYSD. So in mild steel, actually, we generally get the clear cut yield point. So there is a stress strain relationship which is linear like this. Okay. And after this point, then there is a clear cut yield point like this. And then this is the, so you really exactly find out the Fy value, yield stress. What is the Fy value for mild steel? Mild steel का कितना रहता है value?
250 Newton per mm square.
So it is 250 Newton per mm square for mild steel. अरे क्या हो रहा है? 250 Newton per mm square means MPa. We can write out as MPa also.
Yes, sir.
MPa means also Newton per mm square.
Huh?
So this is 250 for mild steel. And there is a clear cut yield point. Exactly, I can define this on the graph. Okay, because the mild steel is having uniform vacancy. And the value is 250 here. And if it is a HYSD bar high grade, then the value is definitely, you know that it is more, and we don't find exactly the yield point. I don't know, it will be somewhere here. So for the simplicity, the theories I have developed.
0.2%.
Yeah, so 0.2% proof stress. So let's say somewhere here, what they do, they mark the strain values. All of you know that the strain values are mentioned here. This is your epsilon means strain, and this is your stress.
Yes.
Okay.
Okay,
So
sir.
corresponding to 0.002 or 0.2%, let's say 0.2% value, or we can say 0.00. 0.002 corresponding to this value. If you draw this graph, okay, then here whatever value you will get, that is a Fy value. So what is this Fy value for high grade steel? High grade steel nowadays it is 500. Correct.
Yes, sir.
And once you apply the factor of safety for different materials, it will be different. Now for mild steel, actually factor of safety is different for different stress types actually. Now we can even discuss that also. So factor of safety for different types of forces is different. Okay. So I will just write down directly. So if you want to, so if you are designing steel structure in mild steel, so which is our IS code is IS 800. So mild steel like ISMB, channels, beams, then say angles. So all that kind of material we are using mild steel, used in generally in the say industries. We are using mild steel like ISMB 200, then ISMC channels like that, angles, rectangular tubes, and so on. So all that is a mild steel having grade 250 MPa. And whenever we design any section, depending on the stresses, stresses or forces in the member, we have different permissible stresses. So let's say if you are taking mild steel, then permissible stress in bending, okay, is 0.66 Fy. This is permissible stress in bending tension, that to tension. So this is, we can say, factor of safety here. Then if there is a pure tension in them, that means permissible bending tension means if you are designing any beam, and all of you know that in beam there is a bending moment, and due to the bending moment there will be stress, bending stress. What is this bending stress? Due to moment M upon
Z.
And there will be bending stress. At the bottom it will be tension, so bending tension, okay, and this will be Z bottom. So the permissible stress, if you are designing here the section, then you should take this value, permissible stress, Newton per mm square. If there is a rod like this, pure tension is there, like this, as we have taken first example, and there is a pure tension, that means it is an axial tension. What is this? It is not bending tension, it is axial tension, purely axial tension. This was bending tension, sigma bt, okay. So the tension caused due to moment is bending tension, so stress is bending stress. So here I can say it is a axial tension stress. So if you want to
0.6 Fy.
0.6 Fy. So if you are designing purely axial member, we have the axial tension in trusses or this kind of rods or suspended cables. So you can take this value, permissible value. If you are designing any beam in steel structure, mild steel I'm talking, then you, for bending, you take this permissible stress. And there is one more stress, that is nothing but shear stress. So you, in beam, you know that there is a shear force also. Shear force. As there is a shear force, there will be shear stress. So there has to be permissible shear stress, which is 0.4 Fy. कुछ समझ में आ रहा है? This is as per
Yes,
code. I'm
sir.
not telling you something different. It is as per IS 800. So if you are designing bending moment, for bending moment, please take these numbers. If you are designing axial tension like trusses or rods like this, take this value. And if you are designing shear, for shear, take this value, permissible values. These are permissible values of stresses, okay? And how to calculate actual stresses? You know that if you want to calculate the stress due to this bending, M upon Z is the actual stress. So this is my actual stress. And this is my permissible stress as per code. Okay. Similarly, this is also permissible stress as per code. And this is also permissible shear stress as per code. And you can calculate the actual stresses from the analysis. M upon Z is actual bending stress. Then T upon A is how much? What? Sigma A T actual. क्या आएगा? Axial stress T upon
में A.
area of the rod, whatever here. And what will be the shear stress actual? Tau actual.
V upon A.
Yeah, so you know the shear force, so V upon cross-sectional area. So find out these numbers and compare with the permissible stresses. That is the design. Okay, we can call it as a strength design. Strength design means checking the actual stresses and comparing with the permissible stresses. So here in this graph, you can mention that this is your Fy, then this is your 0.6 Fy, then this is your 0.66 Fy, 0.6 Fy, and 0.4 Fy. Different values for different forces. Now, can you understand what may be the reason that shear stress is permissible value is very less? That means we can say that factor of safety for shear is very high. What is the reason of this? You can see for tension it is less, for bending tension it is more, and for shear stress it is very less. I mean to say, what I am saying, factor of safety or permissible stress.
Concrete is very weak in
No, this is
shear.
not concrete steel. So for bending stress, factor of safety is less, and for shear stress factor of safety is more. समझ में आ रहा है कुछ? इसलिए ये वैल्यू ये है ना.
Yes, sir.
See, whenever I say permissible stresses are less, that means factor of safety is more or less? More. Because whenever I calculate any permissible stress, I divide that by factor of safety. समझ में आया? This is permissible stress, na? Yes. That means factor of safety for shear is very high. क्यों है ऐसा?
Steel is weak in shear.
Generally, not. It is not said like that, but generally, what happens? See, shear failure is a brittle failure, and brittle failure is catastrophic. It doesn't give any warning. Okay, so generally, for that purpose, for any material, shear stresses, permissible stresses are less. That means factor of safety for shear is more always, because due to shear there may be brittle failure without any warning. So it is always we keep this factor of safety more for shear, always for any material. We cannot say that it is weak or that, but we are considering more of factor of safety. Okay, that is the main reason having you will find this for any materials. For shear we are taking more factor of safety, and that's why the permissible stress. So if you say 0.66 Fy का value कितना आएगा, you just see the values. So it is something 165 will be the value for this. For axial tension it is 150, and for shear it is 100 only permissible. Okay. I am multiplying 250 into 0.66. That is this value. Okay. Similarly, for concrete also we are having permissible stresses which are different. So I have only discussed this axial compression value FCK. Okay. This 0.45 FCK is for axial compression. And axial compression also code is giving not 0.4 FCK, but it is taking 0.4 FCK. So whenever you design any column, take 0.4 FCK. Now there will be lesser value for shear. Definitely yes. इससे कम होगा ना. So permissible shear stress will be different for concrete. permissible axial compression value will also be different for concrete. So अलग अलग रहे, जैसे steel में वैसे भी उधर भी रहते हैं. So what are those values we can discuss in detail whenever we will learn the design of beams columns. In next month actually the sessions will start regarding the detailed design. So these are the basic understanding and basic design methods. So we can discuss, we will even solve some problem by approximate methods so that you will understand the concepts. So we have understood this permissible stresses, stress strain graph, and how to design simple members by approximate and simple methods or thumb rules, we can say. Any questions? कोई questions है क्या?
सर डिजाइन कैपेसिटी एक बार और बता देते हैं.
डिजाइन कैपेसिटी
यस सर.
ऊपर वाला क्या? कंक्रीट या
sir.
स्टील?
कंक्रीट.
See, let's say we have a compression force on the column.
Yes.
Ultimate compression as 1000 kilonewton. Let's say, okay. Now I am asking you, please design the section for this column. Okay, for 1000, so that it can take 1000 kilonewton load. So whenever we design, we need to multiply. You know that permissible stress is nothing but force upon area. And now we are interested in finding out the area. So if I want area, then I will divide this ultimate load by permissible stress 0.4 FCK, 0.45 FCK. Okay. So force upon permissible stress. Area is this much. Area required, I would say. This is area required. And I will provide this 300 by 300 square root of this. And we always increase the section. We don't exactly cut to cut design anything. We always design on the little on the higher side. Round numbers.
ओके सर.
समझ में आया कुछ? सिंपल है ना.
sir.
एरिया इज फोर्स
Yes.
अपॉन
सर
परमिसिबल स्ट्रेस.
एक कहीं पर नंबर ऑफ बार्स निकाले थे वो नहीं समझ में आया था थोड़ा मुझे.
हाँ तो ओके, नंबर ऑफ बार्स वो ऊपर था. ओके. Now here see. Now you know that in beam there is a bending moment due to load. Let's say it is a simply supported beam. So moment is, ultimate moment is WL square by 8, 20 kilonewton meter.
Yes sir.
Once you know that moment is nothing but force into this lever arm. So either it can be C into D or it can be T into D, force into distance, right?
Yes
Now
sir.
you know the moment, you know the distance,
Yes
and
sir.
T is unknown. So T I can calculate. Let's say it is a 67 kilonewton, this 20 divided by 0.3. Now I know the force or tension in the steel, and I know the permissible stress. ये मेरा permissible stress.
Yes sir.
So again same force upon permissible stress, force upon permissible stress.
Permissible
A
stress.
permissible stress for steel is different. So I am taking 0.87 FY. If it is a concrete, it is 0.45 CK. Right?
Okay sir.
Yeah.
ऊपर में ही था सर.
Okay. Any other questions?
No sir.
Sir, I have a general question.
Okay.
So when we design anything, we use IS code like 100% IS code, or we generally sometimes modify or alter according to the site condition. Or it is strictly according to the IS
It's
code.
not strictly, because see, IS code is a recommendation or it is a guideline. So whenever I say recommendation and guideline, the word is guideline.
Yes, sir.
So you should follow the code, but as per engineering judgment, if your philosophy of the structural engineering is clear, and if there are some issues with respect to the site conditions, and your theory knowledge is also perfect regarding the overall philosophy of the structural design, then you can take certain decisions which may be out of code. Okay. So there is, I generally say code is not a god. It is also developed by people by understanding different theories and by experimenting so many, we can say, trials and errors. And on the basis of that, the codes are designed depending on the previous, we can say, performance of the structure and so on. There are a lot of parameters on which the codes are generated. So it may be previous experience, it may be previous structure performance, it may be the theoretical analysis which we do in softwares and manually, it may be experimentation done in the lab. So many parameters involved and the codes are prepared. Now, if you feel that in your problem, if there are certain things which you want to ignore or where you want to take a chance, let's say our code is saying the minimum steel percentage for column is 0.8%. Okay. And at certain point, if this value is getting lower, let's say 0.79%, thoda hi problem aa raha hai. So this decision you can take on your experience and on your risk, we can say, on your judgment. This is also possible. Yes, this value is less. Somebody will say it is unsafe. No, it is not unsafe. It is just, it's not 0.79 is not a big number, means difference than the 0.8. So either this kind of decision, or there may be certain decisions where your behavior is, say, two-way one-way slab का मैंने बताया था, पता है ना? Do you know two-way one-way
Yes,
slab?
sir.
Ly by Lx
Yes.
Less than 2. So if it is 2, somebody said, कौन बोलेगा 2-way ले लो, कौन बोलेगा 1-way ले लो. See, code is now neutral about this, because they have not given that less than or equal to 2. They have just given less than 2. So in that case, you can take your decision in that. Now, do you know in column minimum percentage steel given by Indian code is 0.8%, and in British code it is 0.4% only. Do you know this?
No, sir.
So only Indian one.
Only Indian.
So now you will say, then British people are designing unsafe, or we are over designing, or what is the समझ में है ना? अभी see, there are two codes. Now the
Yes, sir.
concrete RCC building is constructed in UK, let's say, and the same plan, same material we are using, let's say, in India. Actually, it should behave same. There should not be any change. Still, the code is different. So see, there are a lot of parameters actually by which the codes are prepared, depending on different countries. See, you may be knowing that our codes are generally not amended frequently. पता है क्या? American codes, European codes, they change the codes every year, almost every year or 2 years, something, and we are not changing even after 10 years. So the reason is our previous buildings are performing well, and whenever you change frequently the codes, the people gets confused also. There is one point, and there is other point that our building is constructed in metro cities like Mumbai, Delhi, Pune, Bangalore, where there is a good quality control. There are engineers who are working on the sites. There are professional structural engineers who are designing the structures. That is one case where all quality people are there. Quality people, quality material, quality supervision, and enough amount of money given to the project by the clients in metro cities. And there are some structures which we are constructing in village area, where there is no engineer, or if the engineers are there, they are not much, we can say, knowledgeable. Then the material available on site is not having good quality, or the people who are working there on site, labor and workmanship, we can say, is not to that much quality, we can say. So there is a, we can say, variety of conditions or circumstances in India, And due to this variety of conditions, whatever codes we have prepared till now, we don't change much because we need to educate those people, and it is very difficult to educate them, and the material quality may not be good. So we are generally having more factor of safety compared with the other countries like America or UK. So you can see this 0.8% we have given in our code, and UK is saying 0.4%. So what may be the reason? Definitely there is some reason. Otherwise, see, as an engineer or as a logical person, I'm saying we are over designing the structure. Like this 0.8%, I'm taking more steel in column unnecessarily because this is minimum steel criteria. And here it is 0.4% in UK. So somebody may say that Indian people are designing heavy. It's not the case exactly. Don't come to the conclusion only by the logic of the numbers. अभी ये 0.8 ज्यादा दिख रहा है, 0.4 कम दिख रहा है, कोई भी बोलेगा ना अरे इंडिया का कॉलम डिजाइन बहुत हेवी रहता है, अननेसेसरी 0.8% कम से कम डालना पड़ता है. This is not so easy to understand these numbers. Even logically it looks correct, because there are many conditions on the basis of which the Codal committee has suggested certain guidelines. Now, as a professional engineer, as a, let's say, knowledgeable engineer, if some columns are demanding me, some situation are saying that don't put 0.8%, can you really provide 0.4 or 0.6%? Okay. Let's say there are some columns, and at that moment I want to take a decision. I can take this decision provided there is a good quality control over the site. There are good quality supervision on the site. I am designing. I am using all my structural knowledge into this. I am understanding the other circumstances around the project, means within that framework. And finally, I am taking the risk on the basis of my confidence and on the basis of knowledge. Then I can take this decision, and I can go out of the code also. Okay. Now, I have just given one example to you, but there are many circumstances where we need to take such kind of decisions. And there is no problem in taking such a decisions, provided you are confident and you have done the study in all respect. Fundamental study is very much important in this. If you are not making any fundamental mistake, you can definitely. For example, one more example I want to just put: permissible stresses. Permissible shear stress as per IS 56 we are using for buildings, and there is one case, permissible shear stresses, the people are using in bridges also. IRC code, Indian Road Congress code, all of you know this. I think it is used for bridges. The value for the same concrete for this IRC code, it is giving little higher values, means higher values. It's lesser factor of safety, I would say. And here they are lower values, I can say. Okay. For the same grade of concrete and so on. So see, the two codes are there. They are Indian codes only. But for different, say, one is for bridge, one is for building. They are using different shear stress value. Ideally speaking, concrete doesn't understand what code is used. It is a concrete, it is a material, it will behave naturally as per its capacity and as per its configuration, right? So there are certain times this kind of variations you will see in different codes within India and even outside India also. So I would suggest think over such kind of things. So it is always you will get this experience through practice, through thinking, through study, through developing your basic concept, and by understanding the whole picture of the structural engineering in totality. Then and then you can really take the decision out of box, out of codes also. See, there are many signature structures all over the world which are constructed now, which are constructed 100 years back, which are constructed even 500 years back. They were constructed, they were designed without any code. Okay, and still they are there. There are many signature structures or ancient structures are there. They are still there. There were no codes. You might have seen those old structures. So no code, still the structures are standing. They are taking the load for which it is supposed to take the load. So now I hope that whatever I discussed now, it's clear to you.
Yes, sir.
Yeah,
Got it.
yeah. So it is very subjective question, and definitely it will require more study, more thinking. Rather, more study means more thinking, I want to say. Go in deep of everything, and then slowly that knowledge will be developed. So actually structural engineering sometimes feels difficult to people. I would say that it is not only 6 months course training, or it is a 1 or 2 year job, or let's say 4 years of engineering. It is nothing like that. It is a continuous process of learning. Today you may be somewhere here. Okay, you are learning through training program. Let's say you learned here in college, you understood the concepts of physics, then mechanics, strength of materials, and you learned the engineering, structural engineering. Then let's say you came to us, you took one training with us, you're taking training here. Then you will join some job, you'll do some project, you'll do, let's say, building project, sometimes water tank project. Then you'll do high-rise building, you'll do bungalows, you will do that, this. Gradually you're going ahead in your career, and during this journey, slowly you will get the experience, you will get the knowledge, you will get the understanding of the subject. And at one point it may happen that you are now, you can see the circle. That means you are getting this picture now gradually as you go ahead, and then actually that overall understanding will develop. So the person who understands this picture very clearly is an experienced person, and he can take decision whatever he want. He's a very free person, I would say, beyond the code. Till then, as a beginner, I would suggest follow the code. In the beginning, follow the code, because whenever you don't know, please follow the code. It is given. But whenever you follow the code, as you ask me the question, definitely it's a really good question. Many times even experienced people don't ask this kind of questions because they blindly follow the code. So don't follow the code blindly. Okay, so this is very important. You create questions, why this value is given like that, why that value is given in code, why to follow this, why to give minimum steel. If there is no force in column, why should I give minimum steel in the column? There is a question, big question. Then you can say why permissible shear stress is given like this. Why for compression it is more, why it is less for this shear stress. Then why maximum steel criteria is given in the code. Then why the stress block of the concrete is parabolic. Since there are a lot of questions you can have whenever you refer the code. Till you get the answer, please follow the code. And follow the code, create the questions, think over the questions, ask to the experts, try to get the answer from the books, from the internet, from the experts, industry experts, whatever, from the professors, and then that will get developed. And as you will see this picture, yes, I'm learning something, and I'm really these are the, we can say, we are connecting the dots which are missing. And as you connect the dots, then the picture will be clear. So this is your, I would say this is nothing but your experience of the structural engineering or any subjects for the time being. So this completeness of the knowledge is really essential. It takes time, it takes patience. But yes, at one moment you will see this circle. Now you don't know where are you. But as I linearly बताया मैंने, college है, हमारा training है, then job रहेगा. There are codes. So there are a lot of things, softwares you are learning. So everything is learning, but try to integrate them together. Once you do this integration, it will be a really, we can say, kind of enlightenment in the training, we can say. There's structural engineering. So if you do this integration of all this, whatever you have learned, that is really enjoyment. I would say that is the happiness of the engineering. So thank you all.
Thank you, sir.
Thank you, sir. Good night, sir.
Thank you,
Thank you
sir.
and good night to all.
Good night, sir.
Thank you, sir.